This paper presents design and force tracking impedance control of two theory of freedom wall cleaning manipulator by adding disturbance observer, short as DOP. The main contribution of this paper can be summarized as follows. First, a new two theory of freedom wall cleaning manipulator is proposed. Second, a novel force tracking impedance control, short as FTIC, is suggested to keep the constant contact force against unknown environment. Third, disturbance compensation algorithm is proposed, which consists of disturbance observer system, short as DOP, and sliding mode control, short as SMC. Finally, a performance of each controller are analyzed and verified by experiments. The whole system to clean the wall of building consists of two parts. One is the climbing platform, and the other is the wall cleaning manipulator. As you can see in the left video, the distance between the manipulator and the wall changes due to various obstacles like frames while the platform climbs the wall. So we propose a two theory of freedom wall cleaning manipulator to avoid the obstacle effectively. Also, we made the test bench to reproduce such a situation efficiently and investigate the ability of manipulator to keep in contact with the wall when the distance between the manipulator and the wall suddenly changes. We have compared three control schemes through the experiments using the test bench. During the experiments, the wall of the test bench changes from negative 50 mm to 50 mm, and the desired contact force is set 20 newtons. In order to track the desired contact force, the FTIC updates the stiffness of impedance model as well as the position of brush simultaneously, but as you can see, it suffers from large deviation from the desired contact force when the distance between the manipulator and the wall changes. However, as you can see, the performance of FTIC is significantly improved by adding the disturbance observer and the sliding mode control. Here is the comparison of contactability of proposed manipulator with only FTIC and FITC with DOP when the moving speed of wall changes from 40 mm per second to 80 mm per second. As you can see in the right video that the manipulator with FTIC and DOP can maintain good contact with the wall. But in the left video file, the manipulator using only the FTIC is easily detached from the wall. Here is the summary of the force tracking performances of a proposed manipulator using only the FTIC only, and the combination of FTIC with the DOP and the SMC. As you can see, when the FTIC combined with the DOP and the SMC, the force tracking performance of proposed manipulator is most excellent compared to others, irrespective of brush times. So the difference between min and max and the standard deviation of tracking error are significantly reduced by the proposed combination of FTIC, DOP, and SMC.